The problem that I want to discuss next is called eliminating a parameter. And it's related to what we were doing last time. We were talking about making graphs of parametric curves. Another way to analyze these curves is using algebra. And I'm going to look at how to do this by going through an example. So here is the parametric curve that I want to look at. This is a familiar problem. And the way that we approached this before is by making a graph. I did that here, and this should be familiar to you from our last lesson. Notice that the picture that I have looks a lot like a straight line. And so the next question that I want to think about is, can I prove that that's a straight line? So the picture suggests the answer, but it's not good enough for math. We want to be able to prove it. And so that's what we're going to look at next. The way that we're going to analyze this problem, we're going to take the pair of equations that we have. We have one equation for x and one equation for y. And we're going to convert that pair of equations into a single equation. And after we do that, we're going to be left with a relationship that does not contain the variable t. And that is why we give this process the name eliminating the parameter, because we're eliminating the variable t. The first step in doing this problem, we're going to take the first equation and solve it for t, and then we're going to use that result to substitute into the second equation. The steps here should be familiar from algebra, although we're using them in a slightly different way. Okay, let's take a look at the first step. So I'm going to take my first equation and solve for t. I'll set that up here. The next thing I want to do on this problem is get the square root by itself, and then I'm going to square both sides. That's the end of my first step. Now I'm going to go on to the second step in my problem. Take the result from the last slide and substitute into the second equation. I set up the second equation here, and then there's the substitution. The square root and the squared cancel each other out, leaving me that result. Now you do have to be a little bit careful. Remember, in order to deal with the plus or minus that we can get, we have an absolute value here. If you look at this problem, if you look at the equation that defines x, you'll see that x minus 4 is always positive in this problem. I can drop the absolute value, and so my final result, distributing out that constant of 3, gives me that expression on the final line. Okay, so that is actually what we were looking for. If we take that result, we have a single equation. What this problem showed us, the pair of equations that we started with, the parametric curve, is equivalent to the single equation y equals 3x minus 12. And notice that that last equation that we have does not contain the parameter t. So we refer to this process as eliminating the parameter. And what we accomplish by doing that, well, the equation we have is familiar. It's the equation of a straight line. And so we have proven that the parametric curve we started with is, in fact, a straight line. That was our goal. So what I'd like you to do next, there's a few problems for you to try, similar to this. Give it a shot. Let me know what you think.